Welcome to Not Milk Never Milk. Subscribe if you're lactose intolerant.
You start by verifying the exact light sensor model and its voltage and interface requirements so you don't damage it. Once confirmed, power down the microcontroller and position the sensor on the breadboard, aligning VCC and GND. You'll then route one jumper from sensor VCC to the regulated 3V or 5V rail, and another from GND to common ground. Make sure to keep leads short to reduce noise. This first wiring lays the foundation for accurate readings and stable communication. Once the power rails are set, connect the sensor's signal lines, analog OUT to an ADC pin, or SDA and SCL to the microcontroller's I2C pins. If using I2C, add 7K to 10K pull-up resistors between SDA/SCL and VCC to ensure clean signaling. Make sure the ADC reference voltage matches the sensor range so readings scale correctly. After that, place a 0.1 microfarad decoupling capacitor close to the sensor's VCC and GND for stability, and then power the board briefly to confirm idle behavior. You finish by calibrating and validating the sensor. Capture baseline readings in complete dark and under a known light source, then compute offsets and scaling factors so values map to lux or relative units. If data is noisy, make sure grounds are common, short, or twist signal wires, and consider shielding long runs. When nothing changes, use a multimeter to confirm VCC and GND voltages and verify pull-ups. This single voltage check often reveals wiring mistakes, preventing needless code debugging.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.